Okay. Let's see. So let's go here. Let's turn this down. Here. Oh, that's strange. I'm still just logging in. Just give me like another minute or two. Calculus. Wow. We want chapter 2. Let me see. I guess we could just do that instead. Come on. Okay, that's what I'll do. And the main thing, hopefully my screen will push, start the broadcast. I should see. Okay, it's looking promising. So I'm thinking that what needed to happen was like an update, because let me not jump the gun, because it does look like it's kind of okay. Look like it's okay. All right, I'm gonna go with it. I can see my image, so that's good enough for me. So welcome, gentlemen. We're pretty much done, right? We're at the home stretch. So I want to say next Wednesday is our last time that we're going to meet on Zoom. So that's the last day of class is next Wednesday, which is May the 3rd. May the 4th, which is that Thursday, which is National Star Wars Day. May the 4th be with you. And Cinco de Mayo, both that Thursday and that Friday, that's the reading period. So the school should be closed. Your final exam should become available that Sunday, May 7th at 11:11 a.m. and is due, it should be the following Friday, which is May the 12th at 11:59 p.m. Also that Friday at 11:59 p.m., that May 12th, that's the hard deadline for all assignments. Now, on Pearson, I may have scheduled the hard deadline for Sunday, May 14th, right? So you might get an additional 2 days, but if you plan on finishing by Friday at 11:59 p.m., then you'll be good. But there might be a couple of extra days factored into there, maybe. But the one that's for sure is that Friday, May 12th. So today I just wanted to focus on chapter 2. As usual, if you have questions, feel free to unmute yourself to get my attention. See, maybe we can get some points out like we did last time, right? Let's see what happens. I don't know what's going to happen. Okay. So if we're focused on chapter 2 today, I guess maybe like 10 minutes a section. We'll just try to spend about, give or take 10 minutes, like 1 or 2 questions per section, unless you guys have specific questions that you'd like to go through, right? So I'm just going to open up 2.1 and do a couple of questions here. Let me improve the score. Continue. And let me try to prioritize questions that we have not done. I'll just start with question A. I'm just choosing a question at random. I'm thinking about 2 questions per section, approximately, give or take. So this section, exponential and log functions, calculus, an initial investment amount P, an annual rate, interest rate R, and a time T are given. Find the future value of the investment when the interest is compounded annually, monthly, daily, and continuously. Then find doubling time for the given interest rate. Okay. Let's take some notes. Let's start here. Come on. Take it from here to here. That looks decent. Okay. Copy and delete. And let's hop over here. Okay, let's paste. Okay, boom. Okay. My pen, so Probably should have done that beforehand. I'm pretty sure the battery is low. Let me try to charge it now. Let's see. It says, so we have compound interest, and basically we're going to be working with two formulas here. I'm just stalling, trying to get my pen a couple of seconds to charge. Originally, when I got this pen, it said like a 30-second charge. Sorry, I think it was more like a 15-second charge. We'll keep it charged for like 30 minutes, right? Now, I don't know, that's always something to work towards as far as like, battery potential, how quickly charge it, how easily can you charge it, how long can you get the battery to last, right? These are things that is practical that we use, right? So, at some point, maybe some of us can like start working on those projects. Okay, so compound interest. So there's a couple of formulas that we're going to be using here. So the future amount is going to be what? How did they do? P. So P times 1 plus R over N to the power of NT. Okay, that's compound interest. And then continuous compound interest, AFT equals PERT. That's how I remember continuous is PERT, right? 2.1, yeah, this is fine. Why does this feel like? Why does this feel like college algebra? Calculus for business. Okay, let's just go with it. All right. So then for part A, it says annually, okay? So the way we're going to factor that in, so for part A, what's the time? 10 years. So the amount in the account after 10 years is going to be given by the principal, which is $750. 1 plus the rate, if it's 2.92%, as a decimal, that's going to be 0.0292. If it says for part A, we're doing annually, that means our N is 1. I guess I'll do that in purple. Our N is 1 to the power of N, again, that's another 1, times our T, which is 10 years. Find the future value, right? So then from there, it's just a calculator problem. And I'll put it in the calculator momentarily. I think I'm gonna go ahead and set up some of these other ones. So then for B, after 10 years, so B is monthly. So it's the same formula. The only thing that's changing is the purple thing, right? Which is the N. So let's copy and paste. Instead of N being 1.
Professor,
Yes.
somebody's trying to get in.
Okay. Let's see. So we got right here, we got him already. This one. And this one. Come on. Okay. Thank you for that. Come on. There we go. Okay. So in part B, again, we're doing monthly. So there's what, 12 months in a year? Okay, so instead of N being 1, N is 12. Whoops, that's the wrong one. So again, instead of N being 1, N is now 12. Okay, and again, we're going to use our calculator to crunch that number. And then for C is daily. Okay. So again, everything is the same. Only thing that's changing is the purple thing. This is going to be C. And if it's daily, our N is what, 365? $365. And for D, if it's continuously, then we use PERT. So for D, the amount after 10 years is going to be the 750. PE to the R, the rate is 0.0292 times 10 years, right? So continuous compounding, that's what we do. Okay, so then for these other guys, we want this guy. Go. that looks good. Here. A long time, but it's a couple of factor deprivation, and then I've been eating poorly. Like I hadn't eaten cheese in maybe a decade, and then I recently started eating pizza. And basically, the way that cheese kind of affects me is like it's basically poison. I get just like this sniffly, and then the weather kept changing. I'm like, man, come on, can you make up your mind, please? So it's okay. I mean, you know, we just push through it and keep moving. Okay. So what I'm going to do for these guys, I'm going to go to my y equals. The only thing that's changing is n. Everything else is staying the same for a, b, and c. So I'm going to say 750 parentheses 1 plus, we got this 0.0292 divided by, I'm going to make that my x because that's changing to the power of 10x. 10, you know, because again, the n is changing there. All right. So then all I should have to do is plug in the n for the different parts. So I'm just going to put the answers directly. Oh yeah. Directly in here. We'll round it to the nearest cents, compounded annually, right? So so for compounding annually, what I'm going to do is call on that function that I just typed in. And again, in that one, our n is 1. So we get, what is that, 14 cents? Because we have to round up. Okay. $1,000, 14 cents. See if we can type it. 1,014. Okay. Monthly, so now instead of n being 1, now n is 12. And we get 1,397. Okay, that looks good. And next, if it's daily, right? We can get this to work. Now n is, let me see, second enter, no, stop right here. Let's try that one more time. Nope, that's still not working. Second enter, now our n is 365. All right, why isn't that not working? I don't understand. 365, okay. What is that, 32, 1,432? Okay, let's get rid of this. 1,432, okay. That's good, okay.
Professor?
Yeah, more people trying to get in?
I don't know. What was the second one?
For B?
Yeah, for B.
B was if the interest was applied monthly. So that means our N was 12. In parts A, B, and C, the only thing that's changing is N, so everything else was static. So I made it into a formula. All right, is that okay?
Yeah, but like, what was the answer for B? Was it like
1,397. So 1,003.97.
okay? What was?
You
Oh,
can you see my screen?
yes, I see it.
Okay. The future value of the investment when it's compounded continuously. Okay. Let's see. Oh, PERT, right? So P, which is what? 750 P times E to the power of N, and no, to the power of what? RT? R is 0.0292 times 10. Okay, that's PERT. And we get 1,433. Okay, boom shakalaka. Okay, I know there's been 10 minutes on this section. I just kind of want to do a quick scan. Let me check on you guys in Zoom. Oh, the doubling time. Let me see, find the doubling time for the interest. Then find, Find the future value when it's compounded, blah, 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 blah. Then find the doubling time. I guess we're using PERT. That's my hesitation. I'm like, okay, wait, are we using the compound interest formula or PERT? Okay, let me use PERT. I'm just gonna kind of wing it. If that doesn't work, we'll go back and work out the kinks. So if I use PERT, let's see. I know this only applies to what I don't want to do. Yeah, see, that's good pay, but I'm not about to. I don't want to do that many. I don't know. I'll sign up for this, but I probably won't do it. Anywho, we're here. Come on. Okay. All right. So let's try PERT. So if we're using PERT, let me see if that's the right one. Yeah, I'm just gonna go with that one. So if we start with 750, right? We're trying to solve for t. So we got this e to the 0.0292 times t. And we want to finish with double that. So what is that? 1500? So again, we're trying to solve for t. The only thing we don't know is the time. 14, 15, right? Okay. So if we divide both sides by 750, we should get e to the 0.0292t equals 2. To get that out of the power, we take the natural log on both sides. That allows us to bring this down, okay? These are gonna cancel. On the left, we're gonna have 0.0292t. On the right, we're gonna have the natural log of 2. Long story short, t is gonna be the natural log of 2 over 0.0292. I think earlier we said something like the doubling time. Let me see. So the doubling time is like the natural log of 2 over k, or your rate, right? And so we got there, eventually, right? We could have either used that, and we also had the half-life formula. It's a similar formula. There might be a negative in there, but we got there, so it's fine. Hang tight first. Is it about the question or somebody in the thing?
Oh, it's just about like the question.
Let me finish this part out and make sure we get it right, and then we can answer questions. Natural log of 2 divided, give me just a moment, 0.0292. So it looks like almost 24 years, right? If we hop back over here, type in integer or decimal rounded to 2 places as needed. So 23.74 years. Oops, not there. 23.74. Okay. Okay. Mr. Lowe, you had a question?
Yeah, I just wanted to know where did you get the 1500 from?
1500, right? So
Right.
the question asks, how long will it take for us to double our money with this account? So right here. So we use PERT. If we started with $750. Double that would be 1500. So I just doubled it because the question asks us, we're trying to find out how long it takes to double it.
Oh, okay.
We're checking you guys in Zoom. Let's see. Let's keep going. Okay, so let's go to the next section because we spent enough time on this one. Let's hop to. Let's go to view. Allow. Okay, so that was 2-1. Derivatives of exponential base functions, base e functions. Okay, let's look at that. Let's do like at least one or two from this section. We'll do about 2 questions per section. Okay, so this one doesn't have that many. Let's start with question number 6, because it's just a question that we haven't done officially together. Okay. Find the second derivative of w with respect to z for the given function. So basically, you just take the derivative twice with respect to z. Okay. Let me zoom in a little bit. Get a copy. Okay, so hopefully it's, well, we won't know until we go to try. So let's keep the question ID in there. Let's copy and delete. Paste. All right. So find the second derivative of w with respect to t. So we're basically taking a derivative of with respect to z. So it looks like we have to use the product rule, right? Because we have basically two factors being multiplied. So the product rule is what? The first times the derivative of the second plus the second times the derivative of the first. Mr. Lowe, you feel like you can do this one? You want to get this one to go? Or walk me through it? Or Mr. Bell, anybody? Feel like they can do this one? Okay, I'll give it a go. All right. So d by dz, or the derivative of w with respect to c. So the first derivative, let me see, the first, which is 5z squared, times the derivative of the second. The derivative of e to the z is itself. So that's the first times the derivative of the second plus the second, which is this, times the derivative of the first is going to be what? 10z. Okay, so that's the first derivative. We could factor out the ez. I don't know how much that's going to help us. Okay, let's do that. All right. So then this is, if we factor out e to the z, then we're going to have 5z squared plus 10z times e to the z. Okay. So that's the derivative of w with respect to z. So then now what we want to do is find d by dz of, that's not a z, d by dz of this guy. Okay. And over here, that's going to appear like this. D by dz, I keep trying to write x, d by dz of this, right? So we want to take the derivative of this guy, and I'll just group it like this. So then we need to use the product rule again. So then the second derivative of w with respect to z is going to be, so the first, which is this, times the derivative of the second, so the derivative of e is itself, plus the second times the derivative of the first. The derivative of the first is what? 10z plus 10. Okay. Notice we can factor out the e to the z from both terms. And I think we can combine like terms. So then it looks like we're going to have 5z, 10 plus 10 is going to be what? 20z plus 10 times e to the z. It's like that's. Okay. So 5, 20, 10. So here, parentheses, 5z squared, 5, 20z plus 10 times e to the power of z. Okay. I'll be right back. Let me go ahead and pull up another question. So take a look at that for a moment. I'll be right back. All right. So it says a restaurant purchased kitchen equipment on January 1st, 2017. On January 1st, 2019, the value of the equipment was this. The value after that date is modeled by this. What is the rate of change in the value on the 21st? So it sounds like and then what is the original value of the equipment on the 17th? It sounds like we take the derivative, right? The rate of change. So we take the derivative, and then that's what? If that time is based on years, I guess you would say 2 years later. Okay. So then if we took the derivative of that value, the derivative of E is itself times the derivative of the power. So then long story short, it should be the negative 0.168 times that value when T is 2. If I need to write that out, just let me know. I'm going to type it in the calculator. If I need to write it out so you can see it, let me get the student.
Can you write it out real quick?
I got you. Let me get a copy. Let's go here. Let's go here. Copy and delete. Okay. Let's paste. All right. So we have that the value is given by what? 14,450 E to the power of negative 0.168 T. It says, what's the rate of change on the 19th? Okay. So then let's go ahead and find V prime. So the derivative of E is itself times the derivative of the power. So the derivative of the power in this case is going to be this negative 0.168 times the original. The original is this 14,450 times E to the negative 0.168. And then the time in this instance. And this is after 2 years. All right, so our time is 2 at that moment. So then from there, it's just a calculator. Okay, this one here. Okay, let's quit. Let's clear. Okay, so then we get this negative 0.168 times 14,450 times E. We got this negative 0.168 times 2. Okay, that closes off the exponent, that closes off the second product factor. So then get this result, rate of change. It's lost its value. Man, that's a high loss. So at that date, it's losing what? Is that per year? Okay, we got this 1734 and 82 cents. This one. Let's be full screen. Okay, dollars per year, right? So we got this 1734.82 dollars per year. That's a lot. Let's see. Let me think. Maybe it might just be the it might just be that power, right? It might just be the negative 0.168. Let me see. Let me think about this. The only other thing I could think to do, maybe that's not 2 years later. Maybe that needs to be 0. Like instead of, we might need to let the value after the date is based on this date, right? Yeah. So I think that time needs to be 0. Let's redo that. But it's not 2 years later. That's actually our starting time. I think everything else stays the same. So instead of that being a 2, I change it to 0. Man, that's even more. 2427. Let's try that. 2427.6. 2427.6. All right. So I think we just interpreted the setup wrong. They base it on the start date is the 2019, right? So it's not 2 years later. That's actually the starting time. So that means our T needed to be 0. The original value of the equipment on the 17th. So then I think we can use that value formula, but let our T be -2, right? So what I'm going to do is call on what we use, and I'm going to remove that prefix, that part with the -0.168. I'm going to remove that because that's telling us about the rate of change. So this should be a copy of the original, and now I want my time to be -2 years. Okay, I think I've made the necessary changes. It should be slightly more than 14,450. Man, that's a lot more. This stuff was moving, I guess so. I mean, it could be 20,220 and 45 cents. Let's see if that works. 20,220 and 45 cents. Okay. So all I did again for part B, I let the time be -2 years. So I just plugged in, I used the original value function that you see here. And I let my time be -2 years. Okay. All right. Okay, let's go on to the next section. If you have questions, feel free to unmute yourself. And let me check on you guys in Zoom. Okay. All right, let's so that was what? 2122. Let's look at 23. Derivative of natural log functions, improve the score, continue. Okay, we did a lot of these. I'm pretty sure those are like reviews. Let me just do question 5. I'll just do at least one question from here. Let's do a similar question. All right, so let's take some notes. Let's copy and delete. Oops. Paste. No, we'll go to the next one. So differentiate. So it looks like it's the quotient rule, okay? So then dy by dx. Quotient rule is what? Low d high minus high d low over low low. So low, stop. So the bottom, which is this guy, times the derivative of the top. So the bottom times the derivative of the top. The derivative of natural log is what? 1 over x. So the bottom times the derivative of the top minus the top times the derivative of the bottom. It's going to be what? 13x to the 12. All over the bottom squared. So it's going to be what? X to the power 26. Okay, now we can factor out, let me see. So this x turns this guy into a 12. We can factor out x to the 12 from both terms. So then we're going to have x to the 12. And just died on me. Let's try this again. Okay. So if we factor out x to the 12, from that first term, it looks like we're left with a 1 minus 13 log x. Okay, that's fine. And then divided by x to the 26. But then this 12 can turn the 26 into what, 14? So then we can do 1 minus 13 log x over x to the 14. One minus 13 log x over x to the 14. One minus 13 log x over x to the power of 14. Okay. Mr. Lowe, did you have like specific homework questions that you wanted to go through before we just do more at random?
Yeah.
Just do the Ask My Instructor. Let's go ahead and pull those up.
Okay.
I'll be right back. I'm sitting there like a lost child. Heater is already on. Like a gremlin. She's coming. Yeah, come on. Come on. You gonna help me teach class? This is boring stuff. You know. So this is how you do calculus. You ready to learn some calculus? I'm talking to my chihuahua. Just let me know once you've sent it. I guess I could be charging my pen. This is the pen that I use for writing. Exactly, I'm curious about everything. No, they ain't. Oh, you just looking for food. There ain't no food up here for you. I know you just want some food. You always want food. Morehouse. Let's see. So what is this coming from? 4.5 integration techniques. Morehouse. It says evaluate. Okay, let's share. Morehouse. Like this. Morehouse. Morehouse. Okay.
Yeah, it's from section 4.5.
That's fine. Okay, so this first one, it asks us to evaluate, use properties. This is substitution. Okay, substitution. Okay, so let me get a screenshot. And take it from here. This type an exact answer. Let's get a copy of that. Okay. Copy and delete. Come on. Space. Okay, we're here. So if we do a substitution, right? So we need to find a u, right? So let's see. If we let u be dx by x, no. Let's let u be, let's try this natural log of x to the power of 7, right? If that's our u, then our du is going to be, the derivative is dx over x, so dx is going to be 7x to the 6 over x to the 7 dx, right? And then this simplifies. This turns this into a 1. Let me think. So then it looks like our du is 7 over x dx, but notice we don't have the 7, so we need to move the 7 to the other side. So then we need to say 1 over 7 du equals dx over x. Right now I think it's in the proper form. We got our natural log of x to the power of 7. We have our dx over x, and we can multiply by. So now we can rewrite the original, right? So now we're ready to rewrite the original. So the original here, if we started with the integral natural log of x to the 7 over x dx, if that's where we're starting, and we're doing u substitution, natural log of x to the 7 is our u. And then we have this 1 over 7 du. That's where we're integrating. Okay. And again, that 1 over 7, we really could just put it in front because it's a constant, so it can really go in front. So this is really 1 over 7 times the integral of u du. Okay. So then from here, the integral of u is what? U squared over 2. So u squared over 2 is going to become u squared over 14 plus a constant. And then if we put the u back, natural log of x to the 7. Natural log of x to the 7 quantity squared over 14 plus a constant. Okay, let's go with this. Natural log of x to the 7 squared over 14 plus a constant. Let's see. Parentheses, natural log of x to the power, that's not a power, to the power of 7 quantity squared. It was over 14 plus a constant. Use parentheses to denote 2 comes down. I don't feel like doing all that. I would just submit it. I think this is okay. Okay. All right. Let's pull up the next one. If you have, if you have questions, you know what to do. Yes.
When you were trying to find du, why did
Say that one more.
when you were trying to find du, why did you divide the 7x to the 6 power over 7 to the x power? I mean, x to the 7 power?
Okay, so are you comfortable with the u that I'm choosing the u that I chose? Is that
Yeah.
okay? So then now when we go to take the derivative of this guy, the derivative of natural log is du over u, right? So it's basically going to be the derivative of this guy divided by that guy, right? The derivative of x to the 7 is 7x to the 6. Then we say divided by x to the 7. So again, the derivative of natural log is du over u. So the derivative of this guy divided by this guy. All right. So then we had an x to the 6 over x to the 7. So then 6 of the x's cancel and 1 was left on the bottom. It gave us this guy. Now we don't have anything that looks exactly like that in the original, but we can move constants to the other side. So we can divide both sides by 7. Now we got our dx over x. You see the dx over x there, right? And so we can introduce constants the way that we did. Let's pull up the next one.
Okay.
This substitution, okay. Let me share right here. Let me plug this thing in. So the last leg. Well, okay, evaluate. Be sure to check by differentiating. So we're doing substitution. All right, let's give it a go. Let's get a screenshot. Take it from there to here. Copy and delete. And then I drop it right, so we can paste. Okay. Okay, so use substitution. So one candidate, let's let u, I'm thinking ax to the power of 7 plus b. So then our du would be 7a x to the power of 6, right? So we got our x to the power of 6. Dx. Now, again, we're going to treat a like a constant. So we're going to do a similar maneuver to like what we did in the previous. We're going to divide both sides by 1 over 7a. So 1, come on. And I just had to make it a point to remember to charge before class. I mean, we're almost done. We're done next Wednesday, so just got to give it a moment to charge. So we're going to divide both sides by 1 over 7a. Okay. So then we're going to have 1 over 7a du equals x to the 6 dx, okay? So now if we make the necessary substitutions, the 1 over 7a can go in front with a similar argument like we did before. We have our x to the 6 dx, and then our u, we're going to say u to the power of 1/2 du. Okay, so hopefully that makes sense. So now we're ready to integrate. So u to the 1/2 becomes 1/7a persists. That's going to become u to the power of 3/2 over 3/2 plus a constant. So if you flip and multiply, it's 2/3. That's fine. 2/3. So then that becomes 2/21a. Our u is this a to the 7 plus b to the power of 3/2 plus a constant. Okay, let's give it a go. Let me charge this while we do these other things. What I'm gonna do, I'm gonna kind of go like this. Yeah, I just want to be able to see this. Okay. Type in exact and use parentheses to clearly denote the argument of each function. Okay, let's do parentheses. We got 2/21a. And we got times, we got a to the power, a times x to the power of 7 plus b. And then all of that to the power of 3/2. Okay, we don't need those. To the power of 3/2 plus some constant. Okay. Nice. Okay. So let's pull up the next one. Substitution, so the cell comes from the same section. Let's share right here. Go ahead and suppress this for right now. Okay, if we're still doing substitution, so let's get a copy. Here, there. My dog is being so good. Copy and delete. She's being quiet, not making a whole bunch of crazy sounds. Sometimes she just be crazy. I mean, oftentimes she's crazy, but she's just animalistic. But it can be kind of annoying when I'm trying to like stream. And so like she's just being real chill. She's kind of walking around, look outside. She did a little bit of like, she does this weird little cough bark. She'll be like, like when she's just looking at random stuff, it'd be so funny. Okay. So let's try the same thing here, right? Substitution. So let's see. Let's let u be, I'm thinking, let's do 1 minus x squared. If that's our u, then our du is going to be what? Negative 2x dx. Okay. So notice we don't have the negative 2, so we're going to move the constant to the other side. So we're going to have a negative 1/2 du equals x dx. All right. I think we are pretty good. Okay. So now if we make the necessary adjustments, the original is going to become, we have this negative 1/2 times the integral is u to the negative 6 du. Okay, so then from here we can integrate. That's going to become u to the negative 5 over negative 5. This negative 1/2 persists. Okay, plus some constant. So then double negative becomes positive. U is 1 minus x squared to the power of 5 over 10 plus some constant. Okay. 1 minus x squared to the power of 5/10. We get 1 minus x squared to the power of 5/10 plus a constant. Okay. -6 plus 1 is -5. Double negative is positive. Let me think about it. 5 times 2 is 10. Double negative is positive. Remember this is something from the beginning? So that derivative is a negative 2x dx. Get a negative 1/2. U -6. Oh, I see what I did. That should be u to the -5. So really that either needs to be in the denominator or it just needs to be a negative exponent. For some reason I wrote my answer, I removed the negative. So really that should be in the denominator. Let's just move it to the denominator. I'll note it as a -5 here, but the negative exponent is really in the denominator. So I'm just going to move it down.
So we need to move it to the denominator.
I mean, we could try putting a negative. It's the same thing. Like it really just needs to be a negative right here, or just move it to the denominator. This should work. Let's see. All right. That's what we forgot to write our negative or incorporate that negative power. Okay. Let's see. So then this one. Okay, let's keep going. So it looks like there's another substitution. Let's share right here. Okay. Now, if that's our U, substitution, let's see.
Professor?
Yeah.
You got for the previous question was correct, right?
It was, yes. The change that we needed to do was the negative. That was all that we were missing, that negative exponent.
Oh.
All right. I'm thinking about a proper U here. If we let U be, if it were x to the 6, we're going to lose the x and we won't be able to match the du. If we let U be 1 over, what if we did, no, I think that's making it worse. I'm thinking like, okay, what if the U were 1 over x to the 6, x minus 6? Then our du would be okay. Let's try that. Let's see if we can get that to work. I need to write it out. Eat. Right. Initially, I was thinking like, okay, maybe let U be x minus 6, but then the du's aren't working out. So I knew I was like, okay, well, we got to try something different. So we're going to try, let's let U be, I'm thinking 1 over x minus 6. Let's see if we can find the du. So then the du would be Yeah, right. So the negative comes down because this is really x minus 6 to the negative 1, right? So then it's going to be negative x minus 6 to the negative 2. I think it's just times 1, right? And then we can say dx. But that seems like it's making it worse. That's not really helping us. What else could we do? Delete du over u. Okay, I'm not seeing the u here because we can't separate it. I'm going to view an example on this one. Okay, if we do that, our du will be what, 1? So it would just be dx. Oh, interesting. So if we say u plus 7, we'll get our x. So then can we rewrite it as u plus 7 over u du? I think so. Huh. Du, yeah, we got that. Notice that if you blah, 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 then there will be an extra term. Yes. I've never done it that way. That's really interesting. I like that. That was cool. Okay, so this, I don't think I've ever done it this way, but it makes sense in the context of what we've been doing. Right? So here's this. This one is our u be x minus 6, right? So then our du ends up just being 1 dx or just dx, right? But note if we do the substitution directly, we have that extra x on top. So then we can capture that by doing u plus 6 equals x. All right. So then now if we incorporate these three different parts, x becomes u plus 6, x minus 6 becomes u, and dx becomes du. Okay. So now this guy, this one we can integrate, right? Because then the following happens. We can distribute, right? U over u becomes 1 plus 6 over u du. Okay. So then that becomes what is that? U. Let me think about that one. I think that's the natural log of u plus 6 times the natural log of u plus some constant. And then we got to substitute back. So u is x minus 6. Plus some constant. That was interesting. I mean, we could move that 6. We could merge that negative 6 with the constant, and we could just say x plus 6. Let me see how they kind of submitted their final result.
Okay.
So if I go to view an example, was that okay? I just want to see how they did their final one. They got absolute value in there. Did they merge it? Yep, they did. Yep. Yes. Yeah, they did. Okay. That's fine. Okay. So then with ours, because we have this, well, we have that x minus 6 and that plus c. So that minus 6 can merge with that c and just create another constant. All right. So then if we account for all of that, okay, this is like, you were just like, what are you doing? Thank you. Okay. That was an interesting question. I like that question. So then if the -6 merges with the C, and if we incorporate absolute value, I'm gonna have X plus 6 times the natural log of the absolute value of X minus 6 plus some constant. I think that's okay. That was interesting. Okay. So it was a similar technique to like in the previous examples where, you know, we couldn't get the DU to match up. So we were moving things to the other side so that the DUs would match up. It was a similar technique, but instead of manipulating the DU, we manipulated the U. Right. I thought it was an interesting question. I had to look it up. I was like, I wasn't sure initially. And then when I thought about it, when I saw the U that they chose, I was like, oh, we're doing a similar technique. Okay. We're gonna go ahead and let this next one be the last one for the day. I think I'm okay. So I think we got a new trick. Let's up. Okay, evaluate. So let's get a screenshot. Here. Let's copy and delete. Okay, I'm gonna drop it right here. Okay. So we're still doing substitution, review substitution. Give it some juice. I'm alternating between charging my pen and charging my tablet. And my phone has its own charger. Okay. All right. Okay. Let's see. If our U were X squared, let's see. Because if that were our U, we wouldn't get the proper DU. So maybe we can do something similar to what we were doing. Let me see. Let's try. Let's let our U be X squared. That means our DU would be what? 2x dx. We're not going to expand that. Let's see. What could we do? Squared. Can we take the natural log? Because letting you, whatever you were that's a lot. We're not going to do that either. Then D would be 10 times that. You would have to do it. This one might be the table one. There's one with the table. I think I'm gonna scrap this U and DU. I'm tempted to say there's a table. Let's just try to get it going. So if we let our U be X minus 4 to the power of 10, then our DU is what? 10 times X minus 4 to the power of 9. No, that's not getting us there either. It doesn't make sense to expand it out. I might have to look this one up too. I still feel like it's the table one, but I don't really know that table technique. I'd have to like think about it for a moment. Let's view an example. I'm not seeing anything here. Come on. Okay. That's fine. Mhm. Oh, it is a similar technique. Okay. So this is similar to like what we just did in the previous, right? Okay. Be x minus 4, right? Our du is just dx, okay? So then also, if we want an expression for x, we also have that what? U plus 4 equals x, right? So we're gonna basically it's a similar kind of technique like we did a moment ago. So then this becomes the integral of x squared, which is going to be u plus 4 squared. This is really interesting. Times what? U to the power of 10 du. Okay. Now that one we can expand, all right? This one is a lot easier to work with. I'm thinking, that's just up there looking at something. We can expand, let's expand that first guy and distribute, all right? So then if we expand and distribute, we're gonna get what? U squared plus 8u plus 16 times u to the power of 10 du. So we can distribute that u to the 10. Okay. So then is this like zoomed in or something? Oh, that's why I was looking like that. I was like, why is it looking, why did it change so drastically? Okay. So then we would add the power, so that becomes what? U to the 12 plus 8u to the 11 plus 16u to the 10 du, right? And then now we can, this one we can integrate. This gives us u to the 13 over 13, 8u to the 12 over 12, 16u to the 11 over 11 plus some constant. And then u is x minus 4. Plus 8 x minus 4. She's warming with the vocal cords. Divided by 4 is 2 over 3, right? So 2 over 3. 16 x minus 4 to the 11 over 11 plus a constant. Okay, that was interesting. Okay, learn something new every day. Okay, so let's go here. And what I'm go a little bit smaller. Okay. So then we have x minus 4 to the power of 13 over 13 plus the next one is 2 times x minus 4 to the power of 12 over 3 plus 16. Let's do 16 parentheses x minus 4 to the power of 11 over 11 plus a constant. Wow. That was so interesting. Wow. Right. Okay. Let me let me go ahead and make a copy of anything that I was writing. Let me make a copy available. Send it to Box. Click on the wrong thing. Box. Spring, calculus, notes, handwritten notes. Right there is good. Okay. So when this bar finishes loading, you'll get a copy of anything that you saw me writing. Did you have any other burning questions before we kind of go our separate ways?
No,
Burning questions?
no,
Is that
sir.
okay? That was really interesting. I like those last couple of questions. Because like the technique where, you know, we manipulated the DU, I have done that one before. I don't recall ever manipulating the U the way that we did. So I was like, okay. So I learned something new there. Okay, well, if there aren't any other burning questions, we're going to go ahead and end the session here. And from one beautiful mind to another, enjoy your weekend. Next Wednesday is our last day of class. So we have 2 sessions next week. And then the following Sunday, a week from this Sunday, the final exam is going to become available. Okay. All right. Have a good weekend. I'll see you next time.
All right, bye, Professor.
Yep. Take care.